one single moment your whole life can turn round. I stand there for a minute staring straight into the ground, looking to the left slightly then looking back down. World feels like it's caved in, proper sorry frown. Please let me show you how we could only just be for us. I can change and I can grow or we could adjust. The wicked thing about us is we always have trust. We can even have
section 7.3, derivatives of other trigonometric functions. Other, because we already know the derivative of sine, which is cosine, and we know the derivative of cosine, which is negative sine. We've already done those ones. So what we still need to learn is derivative of tan, cotan, secant, and cosecant. And I've given them to you right here. Okay. Now we're going to prove a couple of them here. We're going to prove the tan and the cosecant, and then for homework I believe you have to prove the other two. You're going to prove them in just the same fashion that we do these ones. So even though the answer is here it is again, the derivative of tan x is secant squared x. We're going to prove that. How are we going to do that? Well, let's write tan in a different way. Let's write it as d dx, the derivative of, what's tan? Tan is sine x over cosine x. So now we can take the derivative of that because we can use the quotient rule. So for the quotient rule, we take the derivative of the top, and the derivative of sine is cosine, and we multiply it by the bottom, which is also cosine x. Then we subtract the top, which is sine x, and the derivative of the bottom, the derivative of cos x, is negative sine x. And then we divide all that by the denominator, cosine x squared. So that would be cosine squared x. Okay, let's simplify. Cosine x times cosine x is cosine squared x. Take away a negative is plus. Sine x times sine x is sine squared x. And it's all over cosine squared x. Hey, look at that numerator. It's our favorite identity of all. Sine squared plus cos squared, or cos squared plus sine squared equals 1. So you end up with 1 over cosine squared x, and the reciprocal of cosine is secant. So you get secant squared x equals secant squared x. That's what we wanted. So we've done it. We've proven that the derivative of tan x is secant squared x. Okay, pretty similar for this one. We're going to find the derivative of cosecant x, but cosecant is the same as the reciprocal of sine x. So 1 over sine x. Now you could use the quotient rule if you wanted, but another way to do this, which I think might be a little bit easier, is to write this as sine x to the negative 1. Now this is different than this. What's this? This is the inverse sine, or arc sine, right? This is actually the reciprocal of sine, and that's what we have here. So which rule are we going to use this time? Chain rule. So what we would do is bring the negative 1 down, keep the stuff inside the same, and our negative 1 would turn 1 lower, which is negative 2. Then we'd multiply that by the derivative of the inside function. The inside function is sine x, and the derivative of sine x is cosine x. So what we end up with is negative 1 times cosine x, well that's negative cosine x, over, this is a flippin' negative, so it goes into the bottom, and you have sine x squared, or sine squared x. Okay, this does not look exactly like what we have up here. But what we can do is, we're going to write this, we have two signs on the bottom, right? So let's write this as negative cosine x over one of the sines, so sine x, times the other one of the sine x's. What do we have to put on top though? We don't have anything left up there. We got to put 1. So what we're left with is negative cos over sine. What's cos over sine the same as? That's the same as cotan. So we have negative cotan x, and then we have 1 over sine x. Well, 1 over sine x, that's reciprocal of sine, which is cosecant x. So we have negative cotan x, cosecant x, or negative cosecant x, cotan x. It really doesn't matter when you multiply the order. We've done it. We've proven it. Okay, good. For these ones, we don't actually have the answer. We've got to find the answer. So we have to find the derivative of 1 over 1 plus tan x. You know what? I think I'd use a strategy very similar to what we just did. Rather than using the quotient rule here, I would do 1 plus tan x all to the negative 1. This is what my fx equals. Just rewritten this. So to get the derivative, I'm going to use the chain rule. Negative 1 comes down, keep the inside function the same, Negative 1 drops down to negative 2. I multiply by the derivative of 1 plus tan x. Well, the derivative of 1 is 0, and the derivative of tan x, hey, didn't we just find out what the derivative of tan x is? It is secant squared x. So let's simplify this. We have a negative 1 and a secant squared x, so negative secant squared x. This is a flipping negative, so the whole thing comes to the bottom, and we have 1 plus tan x. Don't put tan squared here, right, because the whole thing is squared. So it's actually all of this squared. And that's your answer. Okay, for this next one, I would use the quotient rule on this one. So to get y prime, we're going to take the derivative of the top, that's negative sine x, times the bottom, so just multiplied by 3x, minus the top, which is cosine x, times the derivative of the bottom, which is just 3, all over the bottom squared. So what we have is negative 3x sine x minus 3 cosine x, all over, now this 2 applies to both things here, 9x squared. And you see you could actually factor out here, we might as well do it. We can factor out a negative 3 from the top. Actually, we better do this because it will allow us to simplify. So we're going to take out a negative 3, and we're left with x sine x minus, or plus, sorry, negative 3 times positive 1 equals negative 3. So plus cosine x all over 9x squared. And it's very nice that this 3 and this 9 cancel. The 9 will now be a 3. So our final answer is negative. You can either write it negative and then in brackets like here, or the other thing they do a lot in your book is they'll put x sine x plus cosine x, and then just put the line to here, and this negative is out front, which refers to both terms on the top, and this is over 3x squared. Okay, I think I forgot something. I think I'm supposed to be a 2 here. I don't know why, but I think that's the actual question I meant to do here. So if you don't mind putting a 2 in there, that'd be great. Careful, this is the argument here of the cosecant. So the whole thing here, what we have is, if you want to write this a different way, we have 2, and then all of this, the cosecant 3x squared, is all cubed, right? That's another way of writing this. So we're going to use the chain rule here. I'm going to start way over here because we've got a lot to write here. First thing we do is bring the 3 down. 3 times 2 is 6. We rewrite the whole inside part. So the cosecant 3x squared will now be to the second power, because that drops. That 3 will drop from 3 down to 2. Times. We're going to look at this inner function here. Again, you're going to use a chain rule here. So we have an outer function of cosecant and an inner function of 3x squared. So the first thing we have to do is take the derivative of cosecant, which I've rewritten right here. Now here's the tricky part. You see this x here? Well, that x right there refers to whatever the argument is. And it just means that you're going to have the same argument here and the same argument here. So you see here our argument is 3x squared. So that means when we take the derivative of the cosecant, we're going to have the same argument 3x squared here and the same argument 3x squared there. If that's confusing to you, which it probably is, I'll show you right now. So what we're doing is we're taking the derivative of cosecant 3x squared. Outer function is cosecant. What's the derivative of cosecant? All this right here. So we're going to put this. We're going to put negative cosecant, but this x is whatever was there, it's 3x squared. So it's negative cosecant 3x squared cotan 3x squared. Okay, now we look at the inner function, which is this highlighted 3x squared, and we take the derivative of that, 6x. So we're going to multiply by 6x. Wow, what a mess. So we've got a 6, a negative, and a 6x. That's negative 6 times 6x is negative 36x. Now, next thing. You see this 2 right here, this squared. You know what that means, right? That's the same as going right here. So it's the same as cosecant squared 3x squared. And we also have a cosecant to the 1 3x squared. So 2 of those cosecant 3x squareds, another 1 of those cosecant 3x squared. It ends up we have cosecant cubed 3x squared. And I think the only other thing we have is this cotan 3x squared. And we're done. That's a tough question. Okay, derivative of the square root of secant theta. Well, let's rewrite this as secant theta all to the 1/2. That's the same as square root. So we're going to use the chain rule. 1/2 comes down. keep the inside the same. The 1/2 drops down to a negative 1/2. We multiply by the derivative of secant theta, and we saw that the derivative of secant theta is secant theta tan theta. So what we have on the top is just the secant theta tan theta. And what we have on the bottom is a 2, as well as secant theta to the 1/2. And I'm actually going to write that, secant theta all to the 1/2. Now, why am I writing that and not putting the square root? Because look, now we have a secant theta on the top and a secant theta to the 1/2 on the bottom. So this is like a secant theta to the 1 and a secant theta to the 1/2. What do you do when you have the same base? In this case, it's secant theta. What do you do when you have the same base and you're dividing? You subtract. 1 minus 1/2 is 1/2. So you end up with secant theta to the 1/2 tan theta over 2, and you can now write this secant theta to the 1/2 as the square root of secant theta times tan theta all over 2. Next one, if y squared minus cosecant xy equals 0, then find dy dx. You know what you're going to have to do here? You're going to have to use implicit differentiation. It's very difficult to get these y's isolated, pretty much, I think, impossible. So you're going to have to use implicit differentiation. So let's go ahead and do that right away. The derivative of y squared in terms of x is 2y, but because it's a y, we have to put y prime, minus the derivative of cosecant xy. Well, the outer function is cosecant, so what's the derivative of cosecant? I wrote it up here in green. The derivative of cosecant is negative cosecant x, in this case our x is xy, cotan x, so we'll put xy again. And we have to multiply that by the derivative of the inner function, this xy. Well, we're actually going to have to use the product rule here. So we're going to take the derivative of x, which is 1, and multiply it by the second one, which is y. Plus, we just rewrite the first one, x, and take the derivative of y, which is 1 y prime. We have to put y prime because it's y. And this equals the derivative of 0, which is 0. Okay, what we're going to do next is multiply this term by this whole giant thing right here, and also this term by that same thing. So I get 2y y prime. Now I have minus a negative, so it's going to be plus, and I have this cosecant xy and cotan xy, that whole long term, but we're multiplying it by this 1y, or this y. So you could put the y at the end, or we usually put it in the front, so I'll squeeze it in there. Okay, now we're going to take that whole thing, that negative negative, which is a plus, and we're going to multiply it by this, the xy prime. So I'm going to rewrite that xy prime first, and then rewrite that whole thing again, that cosecant xy cotan xy, and all of that equals 0. So I see a y prime in the first term and the third term, but not in the second. So I'm going to move the second one over, and at the same time I'm also going to take a y prime out of the first and third terms. So I get y prime, and what I have left is 2y plus x cosecant xy cotan xy equals, all this moves over and becomes negative. Negative y cosecant xy cotan xy. We're ready to divide both sides by this long thing, which I'm not even going to say because it takes so long. So I'm left with y prime equals all of this, negative y cosecant xy cotan xy, all divided by this mess here. So 2y plus x cosecant xy cotan xy. Crazy, eh? It's almost bordering on silly, but that's it. That is the derivative. Okay, last one. Yay! Finding the equation of the tangent line. Boo! It's going to take a while. To get the equation of the tangent line, I need two things. I need a point, I need a slope. Point, well, I have the x value. The x value is pi over 3. How am I going to get the y value? I'm going to plug pi over 3 into here. So the y value is equal to sine pi over 3 times tan pi over 3 divided by 2. Okay, pi over 3 is 60 degrees, and sine 60 degrees is root 3 over 2. And this will be tan, if you take pi over 3 and divide by 2, you get pi over 6. So that's root 3 over 2. Pi over 6 is 30 degrees. You know what tan of 30 degrees is? You need to know what it is. It's root 3 over 3. So you're multiplying by root 3 over 3. Root 3 times root 3 is 3. 2 times 3 is 6. Hey, you end up with 1/2. Not bad at all. So this is our point. Now, to get the slope, how do you get the slope? You take the derivative. So we need to know what is y prime. How are we going to do that? Looks like we're going to use the product rule. We have the sine x and we have the tan x over 2. So take the derivative of sine x, you get cosine x, and then just rewrite tan x over 2. Plus, just write sine x. Then we take the derivative of tan x over 2. So the derivative of tan is secant squared x. So it means we're going to have secant squared x, but in this case it's x over 2, times, we also need to take the derivative of the inside in this one. I mean, we had to take the derivative of the inside of this one too, but the derivative of x is just 1, so there's nothing to write down. But you do need to take the derivative of this. What's the derivative of 1 over 2x? It's 1 over 2. So if we just simplify that a little bit, you get cosine x tan x over 2 plus 1/2 sine x secant squared x over 2. There's really not much you can do. So we need to know what the slope is when x equals pi over 3. So I'm going to plug pi over 3 into all these x's. Cosine pi over 3. Tan. Okay, I'm going to simplify this right now. Pi over 3 divided by 2, we already did that up here, and it's pi over 6. Plus 1/2 sine pi over 3. Secant squared pi over 6. Cosine of pi over 3, so this is cosine of 60 degrees. Well, that's 1/2. Tan of pi over 6, that's tan of 30 degrees. We already did that. It's root 3 over 3. Plus 1/2 sine of 60, pi over 3 is 60 degrees. Sine of 60 degrees is root 3 over 2. Now here's a pain. It's going to be something squared because it's secant squared. The secant value for pi over 6. Well, personally, I can't memorize that. So here's how I do it. I think secant is the reciprocal of cosine. So what's cosine of pi over 6? Cosine of pi over 6, that's cosine of 30 degrees. That is root 3 over 2. So that means secant would be the reciprocal of that. It would be 2 over root 3. Okay, let's simplify. Root 3 over 6 plus, let's just do the first two, root 3 over 4. And here we have to square, so you end up with 4 times root 3 squared is 3. So we've got root 3 over 6 plus, we can cancel these 4's here, which is very nice. So we end up with root 3 over 3. We need common denominators, which are 6, so we'll leave the first one the same. But we have to multiply top and bottom by 2 here, so we get 2 root 3 over 6. 1 root 3 plus 2 root 3 equals 3 root 3 over 6. Simplify these, you get a 1 and a 2. Our slope, because our derivative, is equal to root 3 over 2. Here's our slope. Here's our point. You're going to put it in slope point form. Y minus y1 equals m. X minus x1. It would be y minus the y value, which we said is 1/2. Equals the slope, which we saw below, or right here, it's root 3 over 2, x minus the x value, which is pi over 3. Okay, we want it in general form, so we're going to have to, I'm going to expand this. I'm going to get root 3 over 2x. I'm going to get minus root 3 pi over 6. I'm going to add this 1/2 and get plus 1/2. Got to get rid of all the fractions, so I'm going to multiply everything by 6. So I get 6y equals, when I multiply this by 6, the 6 and 2 will cancel, I'll be left with a 3. 3 root 3x. 6's will just cancel here, minus root 3 pi. When I multiply by 6 here, 6 and 2 cancel, I'm just left with a 3. 3 times 1 is 3. Got to keep the x's positive, which it is right now. Need to move everything to the right hand side. So 0 equals, or I'll put at the end, equals 0. 3 root 3 x minus 6y plus, I'll put the 3 next, doesn't matter, and then minus pi root 3 pi, I can't remember the better way to do it, I'll do it like this, equals 0. We did it. Practice, 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 people.
Try your eyes, mate. I know it's hard to take, but her mind has been made up. There's plenty more fish in the sea. Dry your eyes.